Sairam, welcome to this third session of the study of aldehydes, ketones and carboxylic acids. Having studied first up the nomenclature and structure of these carbonyl groups and some general reactions of the preparation of aldehydes and ketones, we happen to study certain specific reactions of aldehydes in the earlier cases. So, today we will be moving forward where we will be studying the reactions associated with preparation of ketones. Before that, we will see the answers for the assignment that was given in the last class. So, what was the first question? Write the molecular formula of pentanal. Now, al indicates aldehydes, which means that CHO group must be present. Pent indicates 5 carbon atoms, so you are able to see in total 5 carbon atoms being available there, and the hydrogens are in such a way that the tetravalency of carbon should be satisfied, monovalency of hydrogen should be satisfied and divalency of hydrogen should be satisfied. So, this is how we can write the formula of pentanal. So, here this is more like a structural formula also. Even in short, if you want to write, you just can calculate the total number of atoms being present. So, if you see here, you have in total of 5 carbon atoms, in this case 12 hydrogen atoms and 1 oxygen atom. So, that formula also you can write. Second question, write the structure of benzene 1,2 dicarboxylic acid. This indicates that there is a presence of benzene ring, and the carboxylic acid group, which is COOH group, this is present at the first position as well as the second position. Moving on to the third question now, explain Rosenmund reaction. This was a named reaction which was nothing but reduction of acyl compounds, where specifically he took the benzoyl chloride. Now, in this benzoyl chloride, the reduction is happening where Cl atom is going out and hydrogen atom is being attached there, where HCl comes as the byproduct and one more hydrogen atom attaches to the benzene ring system, which causes it to form benzaldehyde. So, generally the byproducts in these important organic chemical reactions are not written during the reaction. The fourth one, explain Gadroman-Koch reaction, one of the industrially important compounds or the reaction where benzene is treated with carbon monoxide and hydrochloric acid. The catalyst used here is anhydrous AlCl3, where benzaldehyde, the compound finally which is obtained, is generally in large quantities which we get. So, these were the 4 questions that were studied in the earlier class, and in this session we will see the preparation of ketones specifically by various methods. Some methods we have already seen yesterday, where general methods like oxidation of primary and secondary alcohols give aldehydes and ketones, where specifically secondary alcohols give ketones. Reduction also had given. We had also seen ozonolysis reactions and all, where they were all general reaction. So, now we will get into some specificities where the first type of reaction will be nothing but preparation of these ketones from acyl chlorides. Now, what are acyl chlorides? Acyl chlorides are given by the formula RCOCl, where this part is the acyl group, RCO group is the acyl group, and this is the chloride which has been present. Now, from these type of acyl chlorides, we are going to generate ketones. Now, if we have to generate ketones, what is the basis for it? RCO is already available. What we after all need is probably this type of a structure, where RCO R dash is required. Now, what are R and R dash? They are alkyl groups, may be same, may be different. It can be either of them. So, if this is the setup, this is generally obtained from the cadmium salts which are there. Now, what is cadmium? Cadmium is part of this periodic table, where the stable cadmium chloride which we tend to get is nothing but having a formula CdCl2, cadmium chloride. So, from this compound we are actually going to react with Grignard reagents, where from the Grignard reagents with the CdCl2 compounds we will get these type of acyl chlorides which are there. So, this is an overview which I gave you, where to obtain ketone we are going to use acyl chlorides. And how do we use this acyl chlorides? We are generally going to have the reaction from cadmium chlorides. So, this part is nothing but utility for further reaction. So, what is the basic starting material now? Let us see in this case, where in the reaction you see that Grignard reagent is taken up, where R MgX we consider it to be Grignard reagents, and this Grignard reagent is being treated with cadmium chloride salt which is there. Now, this type of reaction generally happens where we know very well that in Grignard reagents, this shows a property of formation of carbanions. We generally know that if we split Rx, we are going to split it as R plus and X minus. What is the reason for this? The reason is X is electronegative. Because it is highly electronegative, negative charge of X, positive charge of R. Now, here this actually gives carbanions. The reason being magnesium is a metallic compound. So, if you see the charges here overall, we know that magnesium is plus 2. From periodic table we can know where atomic number of magnesium is 12. It can lose 2 electrons to form a noble gas. X indicates halogen, so that will have minus 1 charge, and if this has to be stable, plus 2 is there, minus 1 is there. If this has to be stable, the overall charge must be equal to 0, therefore, this has to be minus 1. So, in such a condition, these Grignard reagents have a very specific property where it can help to generate carbanions. Now, the moment we know now that they are able to generate this carbanions which are there, here the product that is formed will be 2 molecules of this compound. This we have now realized that this is negative, this is positive. In cadmium chloride, we know very well that cadmium is positive, chlorine is negative, because cadmium is a metal. All metals will be positive in nature. So, the combination you know very well that unlike charges attract. So, what are the unlike charges here? R is a negative one, cadmium is the positive one, and realize that cadmium is in plus 2 state here. If you see cadmium plus 2, Cl minus 1. So, when you do such a cross multiplying system, you get this cadmium chloride. So, when cadmium is plus 2, there is no oxidation or reduction happening here. So, therefore, for the sake of balancing, it will be R2CD. This R2 came because cadmium is in plus 2 state and R is in just minus 1 state. So, for balancing you need it as R2CD. So, with these basic aspects, now we have to see what are the byproducts that are available in this. So, what are the byproducts here? If you see R2 and CD has already been taken in. There are 2 magnesium atoms, 2X and 2Cl which is there. So, this directly what you can do here is write it like this, which indicates that magnesium is in plus 2 state, X is minus 1, Cl is minus 1, therefore, it can be distributed. 2 is for the sake of balancing of this reaction. So, this is the original reaction which is there, where the cadmium compound which is there is supposed to be used here now. This cadmium compound which you have got will be treated with acyl chlorides. Though the heading of the system says from acyl chlorides, the preparation of this is also important because this is not obtained in general cases. So, whereas cadmium salt is readily available, Grignard reagents are readily available. So, you have to prepare a cadmium salt with the organic alkyl group and then form this. So, what is the next thing now? RCO is readily available, R2 is readily available here. So, for my understanding, because I do not want a confusion, what I will try to do here now is, since I have to have it as R and R dash, let me take this as R dash COCl. Now, what is R dash COCl? It is nothing but can be same alkyl group, may not be same alkyl group. So, in this case now, since I have to get RCO R dash, this already I have it as 2, this I will take it as 2 moles. So, the moment I take this as 2 moles, in total now you have 2 R2 here, 2 R dash compounds and 2 carbonyl compounds. This can totally be taken as 2 RCO R dash. See the byproducts here, there is 1 cadmium and 2 chlorine. So, you are again going to get back CdCl2. So, the moment you see this reaction, one thing can be clear for you that this can be a reusable reaction because the byproduct CdCl2 can again be used to the first step. So, this is one big advantage that you see in this type of reactions where even the byproducts can be utilized in the further case. So, this is how we can prepare ketone from acyl compound. So, just as a revision, let us see that part once again, where Grignard reagent is treated with cadmium chloride, you are able to get R2CD. That R2CD, what is that basically? It is an alkyl compound on combination with cadmium that is treated with an acyl chloride, and you get ketones along with cadmium chloride, which is the byproduct. A good thing about here is that the byproduct need not be wasted, it can again be used in the first reaction. So, this is one of the ways to prepare ketones from acyl chlorides. Example reaction where even general reactions you can take up. So, what is the first thing that they have taken there? They have taken a carbon compound which is nitrile having 3 carbon atoms. Now, what are these 3 carbon atoms here? We can name it as prop. So, you can either name it as propane cyanide or propane nitrile, you can name in this cases. So, what is this doing here is, it is combining with C6H5MgBr. Whenever we do reactions, first identify which is the positive, which is negative, and we know very well that it is just about attracting one positive from one side and negative from other, because like charges repel, unlike charges attract. So, here in this case, carbon electronegativity is same. So, difference only comes here, this will be delta plus, this will be delta minus. What about the case of Grignard reagent now? Here also we can see that as already been discussed, this can be delta plus, this can be delta minus. Moving further now. So, what do you understand here? The positive part should react with the negative aspect which is here, the negative part should react with the positive aspect which is there. So, what do we get here is, in this reaction, the triple bond is a weak bond because it has 1 sigma and 2 pi, and we already know that pi bonds are the weak bonds. So, one of the bonds is broken here, and that is how you get CH3, CH2, C and then N. So, one bond is broken here because there is a reaction which is happening, and the moment it breaks, what happens? The negative part comes and attacks the electrophilic positive carbon. So, what is the compound here forming? C6H5. This is the negative part here, that is why it has come. What is the positive part here now? It is MgBr. So, MgBr part is the one which is attached here. So, this is more like an intermediate, but this understanding is important because we consider the reactions at various places. Now, to this what we do is, we undertake hydrolysis. What is hydrolysis? Utilizing water, breaking the water and then attacking it at respective places. So, in the acidic medium, H plus here indicates acidic medium, H2O is the water. How does water split? We know very well that the splitting of water is always H plus and OH minus. So, the moment it splits as H plus and OH minus, this is in case where we have to segregate it in terms of the ionic forms. But now, here it is more about the formation of ketonic bonds, where this sort of hydrolysis will break the bonds which are present here. So, what are the possible products that we see here is, for this balancing of the entire reaction, we rather use 2 moles of H2O. So, what happens here with the usage of 2 moles of H2O, where this compound which is present here can lead to the formation of ketone CH3, CH2, C double bond O, C6H5, and the byproduct with respect to Grignard reagents can be obtained. So, this is the main product that we have, and the byproducts are further substituted in these cases. So, this is how we observe the entire reaction in these cases, and we see that the ketonic part which is obtained there is named as propiophenone. Now, why is that? Is because the phenone part, that is the benzene part, is present as C6H5, and to that a COCH2H5 group is attached. In the figure here, you are able to see it as C2H5, whereas in the explanation you saw it as CH3CH2. It is nothing but splitting up into various aspects. So, this is how we can analyze these type of reactions where the byproducts are not considered for overall reaction conditions. Moving further through the third reaction that we have, which is Friedel-Crafts acylation reaction. This was something that you happened to study even in the first year, where benzene compounds are treated with acyl related compounds. Already we know that benzene as C6H6 and acyl compounds are nothing but RCOCl. These are the acyl compounds which are there. Now, in this case, this is nothing but the electrophilic substitution reaction, where you see that R and C, the electronegativity parts are same, because this is also carbon compound. The difference will come, this will be positive, that is damn sure. There could be a negative charge here as well as negative charge here, because both are electronegative. So, now the question is, will this bond be broken, that is the CCl bond or CO bond, because both of them have a difference in electronegativity. So, where is the breaking easy? That is the next aspect that we have to consider. So, breaking is seen easy in this case, because here if you want to break the bond, it is just one bond. But if you want to break C and O, you have to break two bonds, one pi bond and then followed by sigma bond. So, therefore, the splitting in these cases happen in this way, RCO plus Cl minus, indicating that this is the electrophile which is generated and Cl minus is obtained. So, what is the overall reaction here? We see that the benzene ring which is there, this is the benzene ring, to this benzene ring, this electrophile RCO and the positive charge is on carbon. So, therefore, that carbon is the one which actually goes and attaches. So, there was originally one hydrogen atom here, you must be remembering this. This hydrogen has gone out and this hydrogen has combined with the Cl that was available and that has formed as byproduct. So, this basic reaction where R can be used as an alkyl group or an aryl group also, any group you can use. The basic ideology here is that there is a cutting between CCl bond, because comparatively this is easier than the RCO bond. So, having cut here, Cl minus combines with the H plus that is given out here, and while combination, the electrophilic carbon is the one which goes and attaches to the benzene ring. So, these are various reactions that we tend to associate with the preparation of ketones, and along with the four general reactions, these three happen to be the specific reaction methods that we use for preparation of ketones. Thank you. Sai Ram.